Okay, so chapter 3, section 3.1, it's about introduction to determinant. So first of all, what is determinant? Here is the definition. For n greater than or equal to 2, the determinant of an n by n matrix A is the sum of n terms of the form plus minus A1j determinant of capital A1j. We'll talk about what this small letter Aij and capital letter Aij represent. We'll talk about that later, with plus and minus sign alternating, where the entries are A sub 11, A sub 12, and all the way up to A sub 1n are from the first row of A. And this is the symbol. Now, just by reading the definition, it may not make sense. Let me provide you one example here, okay? Suppose I have a matrix A. So let me consider 3 by 3 matrix. Okay, let me consider 3 by 3. So the first one is A11. So the first row, first column. The second element here will be first row, second column. First row, third column. Second row, first column. Second row, second column. Second row, third column. Third row, first column. Third row, second column. Third row, third column. Okay, A11 means this is the position. Okay, this lowercase a11 represent this position right here. And what is, if I write A11, what does that mean?
First row, first column.
What it means is, this means you ignore the first column and first row, and whatever is remaining, that is denoted by the capital letter A sub 11. This is very important. Okay, so how we represent, I mean, what does this represent? What is this small letter A sub 11? What does that mean? And capital letter A11, what does that mean? So what it means is you ignore the first row and first column. Whatever is left, write it down. So I ignore first row, first column. So the remaining is 822, 823, 832, 833. Okay. And if I write A1, 2, for example, what that means is you ignore the first row and second column. So ignore the first row and second column. So the remaining is A21 and A2. See here, for this one, I ignore first row, ignore that, and then ignore the second column. So the remaining is A21, A23, A31, A33. In the same manner, if I write A13, so I need to ignore, I need to delete first row and third column, and whatever is remaining, I'll write there. So first row and third column. So the remaining is, you just delete that first row. Okay, delete that first row and delete the third row because there is 1 and 3. So the remaining is A sub 21, A sub 22, A sub 31, A sub 32. That's what it means. Okay. Now let us look at this example right here. And determinant is this, but first of all, we should know what is A sub 11. So here you see the formula determinant, that's how we define the determinant. But what is here A sub 11? What is that? That is 1. Okay, this is first row, first column, the element there. A12, so that means the first row and second column, which is 5. first row, third column, which is 0. Second row, first column, which is 2, right there. Second row, second column, which is 4. Second row, third column, which is -1. So in the same manner, third row, first column, which is 0. Third row, second column, which is -2. Third row,
Hello?
third column, which is 0. Now remember the definition, the definition of the determinant. So determinant A is A11. We already know the mean, what is that value. So what is this A sub 11, the capital letter A sub? Well, let us write it down. So this means you ignore the first row and first column. So the remaining is, we need to find the determinant of 4, 1, -2, and 0. So that's our A11. And we need to figure out what is A12. So A12 is given by, I need to ignore first row and second column. So ignore first row, second column, delete that. So whatever is remaining, write it down, which is 2 and -1, 0 and 0. And A13, that's what we need. That means we ignore or delete first row and third column. So I delete first row and third column. So the remaining is 2, 4, and 0, -2. And now, so determinant of A is, determinant of A, that is the formula. Determinant of A is given by A sub 11, lowercase a sub 11, capital, and then determinant of A sub 11, uppercase A sub 11, plus, minus A sub 12, A 12 plus A, hold a second, this is determinant. Determinant of A sub 12 plus A sub 13, lowercase a sub 13, and determinant of A uppercase A sub 13. Now the sign will change like this, okay? Positive, negative, positive, negative. If it is 4 by 4, we'll have positive, negative, positive, negative, positive, negative. It goes that way. So we'll talk about the how we can find out sign later. So that's the formula. That's the, this formula comes from the definition. Now let us substitute the value. A11 is 1, determinant of A sub 11, which is determinant of 4, -1, -2, and 0, minus A12, which is 5, and then determinant of A12, which is 2, -1, 0, 0, and plus A13, lowercase A13 is 0, and determinant of A13 is 2, 4, 0, -2. And so what the determinant actually means is you multiply this way, okay? So you multiply, just do the cross multiplication starting from 4. So 4 times 0 is 0, minus -2 and -1. So that's how we find the determinant. For example, if you have A, B, C, D, so the determinant of this is, determinant of A, B, C, D actually means AD minus BC. This is called determinant, okay? AD minus BC. And so determinant of this is 0. 4 times 0 is 0, minus this, minus 5 times determinant of that will be 2 times 0, minus 0 times -1, and plus 0. Okay, everything is 0, so I don't have to do that. Now, what is the answer? Here, as you can see, this will be 1, and this will be -2, and this guy will be 0, minus 0, and plus 0. So that's going to give me -2 is your answer. That's how we calculate the determinant. Now, there is another symbol you need to know. Let us define cofactors now, because later this it can be done by using the cofactor expansion. As a matter of fact, this is what we'll be doing later on. Okay, we'll be using cofactor expansion to find the determinant. Now, before we use the cofactor expansion, first of all, we should know what is cofactor. Let us talk about that briefly. Now, I'm going back to the same examples that I considered at the beginning. Here, okay, this is the matrix A, and we know what is this lowercase aiz or a11, a12, and uppercase a11, a12, a13. We all know that. Now, cofactor. So when I say cofactor C11, what that means is, it means -1 power, I'll write this way, Iz. In general, I call it Iz, I plus j, Aiz. That's how we define the cofactor. So what that means is, if I want to find the cofactor of, let's say, C11, okay, cofactor C11, that means -1, I is 1, j is 1, and Aiz means A11. So that means -1 power 2, which is positive A11. Now, cofactor C12, this means -1. Here is the formula, I is 1 plus 2, A12. So this will be negative, so negative A12. So C13 equals -1, then your I is 1 plus j is 3, A13. So that's going to give me -1 power 4, which is positive. So A13. Again, the sign will be positive, negative, positive. So that's how we define the cofactors. So, okay. Now we'll be using this cofactor to find the determinant for the next example. Now,
Sir, I
okay, so in cofactor, so I forgot to put this determinant of that. So determinant, so that means you're going to get determinant, negative determinant. So this is determinant and determinant, okay? So that's what it is. And okay, example 2. Let us, oh, by the way, if you are given a matrix, let's say A equals 1, 2, 3, 4, 5, 0, 7, 1, 5, for example, and if you want to write determinant of A, you can write either determinant of 1, 2, 3, 4, 5, 0, 7, 1, 8, 7, 1, 5, or you can simply write two vertical line and put these numbers this way. If you write the matrix symbol, you must write this determinant, DET at least, okay? Determinant and then the matrix symbol. So this, if you don't want to write the determinant, this word, then you can actually use this vertical line. So when something is written, the matrix is written under the vertical line, this two vertical line, then this means determinant. You don't have to write that word determinant for this anymore. Okay, that's how we, that's the symbol, that's how we represent the determinant. As you can see in example 2, since this is given under this two vertical line, it means we need to find the determinant. The same questions can be given this way. Okay, example 2 can be given. Find determinant of 1 2 0 3 negative 1 2 2 0 1. You can write this way too. You see, if you write the matrix symbol, then you must write this word determinant. If you just write the vertical sign, done. Okay, now for this one, let us use the cofactor expansion to find the determinant of this. Okay, using the cofactor. So first of all, let us calculate cofactors. So what is A11? You already know, which is 1. So that means first row, first column, A11 is this. A12, which is 2. A13, which is 0. C11, cofactor. We're talking about cofactors now. Cofactor means always negative 1 power 1 plus 1. Okay, remember the formula. C11 Ciz equals negative 1 power I plus j, a determinant of Aiz. So that's the formula. Or you can write this way. Or you can write negative 1 power I plus j, and then you can write Aiz. You can write this way too, because once I use the vertical line here, I don't have to write determinant sign. So C11 will be negative 1 A11. C12 is negative 1 power 1 plus 1 plus 2 determinant of A12. C13 is negative 1 power 1 plus 3 determinant of A13. Now let us find what is A11. So that means you see negative 1 power 2 is positive. So determinant of A11 means you ignore the first column and first row. So you left with negative 1, 2, 0, and 1. That is your cofactor 1. I mean cofactor C11. Now second cofactor C12. This will be negative 1 power 3, which is negative, and then the determinant A12. So A12 means we are deleting first row and second column. So let me delete first row and second column. So the remaining is 3, 2, and 2, 1. And this guy, which will be negative 1 power 4 is positive, and determinant of A13. So which means you ignore or delete first row and third column, remaining 3, negative 1, and 2, 0. So let me calculate what is that. So this means negative 1 times, you already know how to find the determinant, negative 1 times 1 minus 0 times 2. So that is your determinant, which gives me negative 1 there. This means negative 3 times 1 minus 2 times 2, which gives me 1. And this,
Negative 1.
so this will be it will be negative 1 power 4, which is positive. So you're going to get 3 times 0 minus 2 times negative 1, which gives me positive 2. So now the determinant will be, so the determinant is 1 2 0 3 negative 1 2 and 2 0 1 is, let me plug in the value there. Okay, so the I will plug in the value there. So that means A11, which we already know, which is 1 times negative 1 plus 2 times 1 plus 0 times 2, and that's gonna give me um, 1. Okay, so don't get confused. This, even though for determinant we use the two vertical line, and if I write this AIZ, it doesn't mean that I'm talking about absolute value. No, this has a different meaning. It is determinant. It's the symbol for determinant. It's completely different from the absolute value. Therefore, the determinant can be 0, determinant can be negative. So yeah, so we'll work on that later. Now, in example 2, whenever I consider all this, a sub 1 1 c11, a sub 1 2 c12, you see what I did here is that I changed the column, but the row remains the same. It's called expanding the first row. In this case, the method that I use here is called expanding first row. Means I keep the row the same. As you can see, a1 row is first, first row, even for C first row, and here also first row second column, first row second column, and first row third column. So we keep that row first row constant throughout this formula, and we call this expanding the first row. In the same manner, you can expand the second row, you can expand the third row, you can expand the first column, second column, third column, doesn't matter. You still get the same answer. Okay, so let us work on example 3. In this case, use a cofactor expansion across the third row to compute determinant of A. So third row means we will expand this. Okay, so expanding third row, the determinant of A will be, remember the formula is now A31 third row C31 plus A32 C32 plus A33 C33. See, okay, I expand this, I write A31, then A32, and then A33. So these are the position that I consider in my formula, and if I do that, we call it expanding the third row. Okay, now let us calculate this. A11, you already, sorry, A31, you already know. A sub 31, which is 0, A sub 32, which is -2, and A sub 33, which is 0. Now let me calculate what is this C31. Okay, C31, that means -1 power 3 plus 1, and determinant of A, let me write this way, determinant I can write this way, A31. Okay, and C32 is -1 power 3 plus 2, A32. And C33, that's what we need in the formula, which is -1 3 plus 3, and that's going to give me A33. So let me calculate that. -1 power 4, which is positive. A13 means you ignore the third row and first column. Ignore third row, first column. Whatever is remaining, you write it down. So it will be positive, and then that's going to be 5, 0, 4, and -1. And this means you can write this down, 5, -1 minus 4 and 0. So that's going to give me -5. And let us calculate the C3 cofactor 32, which is -1 power 5, which is negative. And then the A32. So A32 means you delete the third row and second column. 32, third row. delete this third row, and then second column. Whatever is remaining, you write it down. So the remaining is 1, 0, 2, -1. And you can calculate that by yourself. And now this one will be -1 power 6 is positive, and 833 means you ignore the third row and third column. So the remaining is 1, 5, 2, 4. And that's gonna give me, let me see, a negative. I'll get 1, -1, -2, and 0, which gives me +1. And this guy will be 1 times 4 minus 5 times 2. That's going to give me -6. So the determinant of A is going to be, the formula is, as you can see, A31 C31 plus A32 C32 plus A33 C33, which gives me, let me just plug in the value. A31 is 0 C31, which is C31 is -5, plus 32 is -2, and C32 is 1, plus A33 is 0, C33 is -6, which gives me -2. So from this example, you notice that when there is 0, okay, when there are zeros, then at the end of the day, you just get 0. So in calculation, it makes life easy. So in general, if you want to expand, if you want to find the determinant, then I suggest you expand the row or column that has more 0 in it. So from now onwards, I'm not going to do all of these because it takes a lot of time. So let's say I want to expand, let's say expanding, let's say R1, okay, row 1. And let's see what happens. This is method 1. The same problem can be done in so many ways. Let me do it expanding. Let's say method 2. Expanding, let's say first row. If I want to expand first row, now we know the formula. What I'm going to do is, I do this, guys. Determinant of A equals A11, we know the formula, and C11 plus A12 C12 plus A13 C13. We know this formula. And we already know A11, which is 1. And C11 is, look at that, C11. Okay, keep this in mind that your sign will be, in this case, your sign will be +1, and then this will be negative in the second step. We'll write that later. So C11 means you ignore the first row and first column. So ignore first row and first column. So you're left with 4, -1, and -2 and 0, plus A12. A12 is 5, and C12 means it will give me the negative sign there. Because remember, the formula is -1 power. Whenever there is a cofactor, we must think this way. Negative, for this one, -1 power 1 plus 2, which is -1 power odd, will be negative. Just keep that in mind. So this will be -5, and C12 means you ignore the first row and second column. So ignore the first row and second column. You're left with 2, -1, and 0 and 0. All right, and then plus A13, which is 0. I don't have to write anything. So that's going to give me 1 times, now you know 4 times 0 is 0, 4 times 0 minus negative 2 times negative 1. Okay, and then minus 5 times, this guy will be 2 times 0 is 0, 0 times this one is 0, so you'll get negative 5 times 0 and plus 0. So that's going to give me negative 2 again. Okay, so you don't have to do all of these process. The concept is the same. I mean, pretty much every process we have written it here, but in a condensed form so that you can save some time. I think you notice that the more zeros that you consider, I mean, the row or column that has more zeros you consider to expand, life is easy. So I want you to try another way. Let's say method 3. I want you to expand a third, let's say third column, expanding third column. So in that case, your determinant of A will be third column. Remember, this third column means this one. So what is the position here? Okay, this one is too big. Just give me 1 second. So the position of this guy right here is A. Third column means this is third, I mean first row and third column. Okay, 1 3, A13, no, C13 plus A. Now this guy right here, what is the position for that? Which is A23. So the column remains the same here. We change the row. So that means C23 plus. Now we need to look at that, which is A33, C33. And we already know A13, which is A13 is 0 multiplied by anything is 0. So I don't have to even write that because this guy will be 0. Already we know. Plus A23, which is negative 1. But remember, the C23, this will be negative. This will be negative because, you know, there will be negative 1 power 2 plus 3. You know, the sign always comes with positive, negative, positive. So this will be negative 1 there, and then negative 1 again. And then your ignore the second row and third column. So ignore the second row and third column. So you're left with 1, 5, and 0, negative 2. Plus the third one is also 0 multiplied by anything is 0. That's it. So now you can write this negative 1 power 5 is negative 1 times negative 1 is positive 1. And then, so that's going to give me 1 times negative 2 minus 0 times 5, which will be negative 2. Okay, that's we can do. All right, so like I said, even though the example 3 tells us to do this expanding to find the determinant expanding third row, but we tried it with expanding first row and also expanding third column just for fun. So you can choose which column or which row to expand to find the determinant. Okay, now let me ask you this question. Example 4. I want you to try this on your own. Just take a few minutes and try to answer these questions quickly, okay? Okay, so example 4, if you want to make your life easy, I suggest either you expand the first column or the third row because that has more zeros in it. So let us expand third row. expanding third row. If I expand, no, not third, fourth, sorry, fourth row. Okay, expanding fourth row. So you're gonna get determinant of this is going to be, the formula is A fourth row, means 4 1, C 4 1 plus A 4 2, C 4 2 plus A 4 3, C 4 3 plus A 4 4, C 4 4. Okay, we know that. Now this is gonna give me A 4 1 is 0 plus A 4 2 is 0 plus A 4 3 is 0 plus A 4 4, which is this 4, and then C44 will be, you ignore that and ignore that. So whatever is remaining, you'll write that down. So that's going to give me 2, 3, 4, 0, 1, 2, 0, 0, negative 3. Notice that the sign will be positive here. This sign will be actually negative, but who cares? It's 0, right? So 0 means this sign will be negative, positive, negative, positive, because 4 plus 1 is odd power. So yeah. So what we got here is that 4 and this 2, 3, 4, 0, 1, 2, 0, 0, negative 3. Now which row or column do you want to expand? Now let us expand the third row again.
Third row.
Now expanding third row, and you're gonna get 4 times third row, means this will be 4 times A 1 1, sorry, 3 1, C 3 1 plus A 3 2, C 3 2 plus A 3 3, C 3 3. So that's going to give me 4 times, this guy will be 0, 3 plus 1 is 4, means 0 and negative 0 and positive, so that's going to give me negative 3, and 3 plus 3 is 6, which means positive. And so you're gonna get, this is gone, so you're left with 2 3 0 1, and so, and then if you just work it out, so you're gonna get 4 times negative 3 will be negative 12, this will be negative 12, and then that's gonna give me 2, and then 2 times 1 minus 0 times 3, so that's going to give me negative 24. Okay. Yeah, somebody asked me whether the determinant can be negative. Yes, we got negative 24. Okay. All right. That's how we
Can I ask a question?
Okay, this is method 1. Okay. Now, if I were you, if I'm a student and if I was given this example, this question, I don't want to spend a lot of time doing this. What I would do is, determinant of this will be, I will use the second method, which is actually, I know that this is a triangular matrix, and so I just multiply 2 times 1 times negative 3 times 4, and so multiplying the diagonal entries, multiplying diagonal entries. So what is that? It's negative 2, negative 24. So that's how we do. I don't want to spend that much of time. As soon as I know that this is a triangular matrix, then for triangular matrix, it always works, guys. So what you do is you just look at the main diagonal and you multiply the diagonal entries. You just forget everything else, just multiply the main diagonal, and that will be your determinant. Okay, this method works only for triangular matrix. Just keep that in mind. Okay, this must be today. And for this section 3.1, I think we are done. And if you have any questions, we'll talk about it in our next class.